Explicit waits in Selenium WebDriver. Explicit wait is used to make the automation script wait for a certain condition to be met before proceeding to the next step. This is useful when working with elements that may not be immediately available or when dealing with dynamic content. How do you perform explicit waits in Selenium WebDriver? First, create a WebDriver wait instance with a timeout of 10 seconds. So the WebDriver will wait up to 10 seconds for the specified condition to be met. Next, use wait.until method to specify the condition we want to wait, for example, the visibility of an element located by its ID. Once the condition is met, it returns the web element, then perform actions on this element. Explain the differences between implicit wait and explicit wait in Selenium. When would you use each of them, and why? Let us see the differences one by one. Implicit wait. It is globally defined. Codes are concise and readable. No need to specify any conditions. Most effective when elements are located within the time frame specified in implicit wait. Performance cause issues can be identified. Where in explicit wait, wait is applied only at targeted issues. Use of expected conditions is mandatory. Most effective when the elements in the page are taking a long time to load. No performance issue are identified. Syntax for implicit wait and explicit wait. getText method in Selenium WebDriver. The getText method is used to retrieve the visible text of a web element or to extract text from specific elements. URL of the application is given. We are going to retrieve the text of the heading highlighted. To retrieve the header text, use tag name locator that is h1 tag. Here we have the code. First, initialize the WebDriver. Navigate to a web page. Find a web element containing the text. Use getText to get the visible text of the web element. Print the retrieved text. Close the WebDriver. Check the console output. Now, you can see the retrieved text. Headless Browser Testing. In Headless Browser Testing, the web browser runs without a graphical user interface. There is no visible browser window, and all interactions with the web page happen programmatically. Let us see an example to demonstrate how to perform a headless browser test by starting Google Chrome in headless mode. First, we create a Chrome Options object and set the Set Headless True option to enable headless mode. Then initialize the Chrome driver with the Chrome Options object, creating a headless Chrome browser instance. Navigate to the Google homepage, locate the search input element, enter a search query, and then submit the form. We have added a short sleep to give time for the search results to load. We print the page title to the console. Finally, we quit the WebDriver to clean up resources. Execute the test as testNG test. It starts the application in headless mode and gives the page title. Pop-up windows. Handling pop-up windows is essential when automating web applications that use them for notifications, authentication, or other user interactions. The ability to switch between windows allows you to perform actions in the context of each window and maintain proper control over your automation flow. How do you handle pop-up windows in Selenium WebDriver? First, get window handle of main window. Get window handles method retrieves a set of window handles for all currently open browser windows. Next, iterating through window handles, the loop assigns the current window handle to the variable popup wh. Then, checks if the popup window handle is not equal to the main window handle. If the condition is true, then switch to popup window and perform actions. Then switch back to the main window. Selenium testNG retry analyzer. To implement test retry functionality using testNG's retry analyzer, we have two classes. First one is a custom retry analyzer class which implements iRetry analyzer. The second one is testNG test class with annotated the test methods. This is custom retry analyzer class, which defines the logic for when a test should be retried. First, set the maximum number of retries by setting integer max retry count equals 3 as a private variable, and private current retry count equals 0. Then, we have the method, retry, which returns Boolean output true or false. iTestResult parameter is used to access and manipulate information about the test methods at runtime. Used in conjunction with retry analyzers to perform actions based on the outcome of a test method. Next, we have testNG test class with two methods such as failing test method 1 and 2. Here, set the retry analyzer attribute to custom retry analyzer class. Then, run as testNG test and see the output. Both the failing test 1 and failing test 2 are failed during execution. So it retried each test 2 times. testNG is a testing framework in the Java ecosystem. Provides a wide range of functionalities for writing and managing, including assertions for validation. testNG's built-in assertions are used to validate the expected behavior of the application. testNG's built-in assertions. Assert equals compares two values for equality. Assert true, assert false. It asserts that a condition is true or false. Assert not null, assert null, asserts that an object is not null or null. Assert not equals, asserts that two values are not equal. In this example, we have 4 methods. First method, test assert equals method. The expected value is 5 and the actual value is 5. If the expected values are equals to actual values, it will pass the test. Otherwise, it will fail the test, and it will return values are not equal. In the second method, we use assert. If the conditions is true, it will pass the test. Third method is assert not null, or null. It verifies if the object is null or not. Fourth method is assert not equals. It will verify if the unexpected and the actual values are equal or not. Let us execute and check the output. How can we exclude a test method from getting executed via the testng.xml file? In this example first, we are going to exclude invalid credentials login method. So only valid credentials login method and logout methods will be executed. Here in testng.xml, we use exclude method equals invalid credentials login and execute as testng suite. See the execution, log into the application, then log out. Valid credentials login method and logout method are passed. Next in testng.xml file, let us set exclude method name as valid credentials login. It will only execute invalid credentials login and logout method. See the execution. Invalid credentials login method shows the error message, and it is displayed. So logout test is failed. How do you specify which browser and platform a test should run on when using Selenium Grid? To specify which browser and platform a test should run on when using Selenium Grid, we use the desired capabilities class. The desired capabilities class allows the user to define the desired browser, browser version, and platform, operating system, for the test. Let us see an example. Create a desired capabilities object. Then, set the desired browser by using setBrowserName method. For example, to specify Chrome, capabilities.setBrowserName, then pass Chrome as parameter. As well, to set the browser version, use the setVersion method. To set platform, use setPlatform method. Here, capabilities.setPlatform, platform.windows. To use these capabilities with Selenium Grid, we need to create a remote WebDriver instance by specifying the Selenium Grid Hub URL and the desired capabilities. String grid hub URL consists hub address and port number. When we execute the test script, it will run on a node that matches the specified browser and platform based on the capabilities we set. Cookies are small pieces of data that a web server sends to a user's web browser and are stored locally on the user's machine. They are commonly used to maintain user sessions, store user preferences, and track user behavior on websites. In Selenium WebDriver, we can work with cookies to simulate different user states and test scenarios. How do you work with cookies in Selenium WebDriver? To add cookie to the browser session, a cookie object is created with cookie name and cookie value and then added to the browser session. Get cookies. To retrieve all cookies currently stored in the browser, use the getCookies method. This returns a set of cookie objects that you can iterate through to inspect or manipulate each cookie. To get a specific cookie, use the getCookieNamed method. Modifying cookies. We can modify a cookie by adding it again with the same name and a new value. This will update the existing cookie with the new value. Deleting cookies. To delete a specific cookie, use the deleteCookieNamed method. To delete a specific cookie by providing the cookie object, use the deleteCookie method. To delete all cookies, use deleteAllCookies.